In this chapter, we are going to talk about how to diversify your portfolio efficiently. The purpose of diversification is to reduce the overall risk of your portfolio. We are talking about two types of risk here. The first one is the market risk, or systematic risk, or non-diversifiable risk. You can use the terms interchangeably. They all mean the same thing. The market risk factors are the risk factors that are common to the whole economy. For example, business cycles, inflation, exchange rates. It doesn't really matter how many stocks you have in the portfolio, you are always going to face those risk factors. The second type of risk is called unique risk, or sometimes we can say firm-specific risk, non-systematic risk, diversifiable risks. You can use all the terms interchangeably again. Those are the risk factors can be eliminated by diversification. Examples of unique risks are shortage of parts in one particular company, sudden death of CEO in one particular company. The firm-specific risks are unique to that particular firm. It is called diversifiable risk because those risk factors can be diversified away. If you're worried about shortage of parts in one particular company, then if you hold 20 stocks in your portfolio, you don't have to worry about this particular risk anymore because all 20 stocks or all 20 companies have shortage of parts. That chance is very small, so you don't have to worry about that particular risk anymore. That is why it is called diversifiable risk. The main idea here is diversification could reduce portfolio risk by getting rid of the unique or firm-specific risk. We can plot the relationship between the number of stocks in the portfolio and the portfolio risk. So we look at the left-hand side picture first. On the vertical line, we have the portfolio standard deviation. On the horizontal line, we have the number of stocks. We first look at firm-specific risk only, so the standard deviation only captures the firm-specific risk. If we hold just one stock, we have the highest level of firm-specific risk, because if something happens to that one particular stock, your portfolio is at great danger. As the number of stocks increase, the total portfolio risk, the firm-specific risk, is gradually decreasing and its approach to zero theoretically. Then we look at the right-hand side. Now we are going to add market risk. The market risk is a constant number. As you can see, it doesn't really matter how many stocks you hold. The market risk is just a constant number. It will not reduce by increasing the number of stocks, because no matter how many stocks you hold, you are still facing the same amount of market risk. For example, political risk, inflation risk, exchange risks. You can't really get rid of them by holding more stocks in your portfolio. So combining the market risk and the unique risk together, the pink line here is the total portfolio risk. When we talk about diversification, we're talking about diversify away the unique risk by holding more stocks in your portfolio, but you can never diversify away the market risk. So to summarize, in reality, it is just not possible to completely reduce the risk of portfolio to zero, because the market risk will always be there no matter how many stocks you hold. You can only get rid of the firm-specific risk by holding more stocks in your portfolio. If you wonder how many stocks is enough for a diversified portfolio, this picture shows you. This picture shows you on the vertical line, again, variance the portfolio risk. Horizontal line, the number of stocks. The blue line is the combined total risk, which is the market risk, the pink one, fixed number, plus diversifiable risk or firm-specific risk. As you can see, around 20, when you hold about 20 stocks in your portfolio, the total risk will approach to the market risk. So you can diversify away the firm-specific risk around 20 stocks. When we talk about a diversified portfolio consists of 20 stocks, I do not mean any 20 stocks. For example, if you hold 20 financial stocks in the US, if something bad happens to the financial sector, very bad news released, then all the 20 stocks you hold in the portfolio will all negatively affected. So that is not a diversified portfolio. When we say 20 stocks, we're talking about 20 stocks in different sectors, in different industries, in different countries to achieve the diversification purpose. Here we have an example of the international diversification. The US stock market accounts for about 50% of the total world equity markets. We also have Eurozone accounts for about 15%, Japan 12%, and UK 8%. So how to achieve international diversifications? I'm going to show you a correlation table in the next slides. This table shows the correlation between any two countries' stock markets. Take a look at the United States and Canada. The correlation is 0.7, which is the highest of all countries. But for diversification purpose, we want to pick any two stocks or any two countries that have the lowest correlation. In this table, for example, the United States and Austria have the correlation of 0.14, which is pretty low. So for diversification purpose, to form a portfolio, you will add Austria stock markets in your portfolio. In the next section, I will show you how to do asset allocation with two risky assets. So the question we try to answer is, if you have $100 and you have to invest in both Google and Apple, how do you split your money? $50 in Google, $50 in Apple, or $70 in Google, $30 in Apple? What is the optimal split? Or what is the optimal asset allocation with these two stocks? Asset allocation is the choice among different asset classes. It is a very important part of portfolio construction. It is also a very important part to control the risk of the portfolio by manipulating the fraction of the risk-free asset versus the risky asset. Now let's take a look at the numeric example here. Suppose you have totally $300,000 to invest. You want to buy a market value of $300,000 of portfolio. You want to put $90,000 in the risk-free money market fund. The remaining $210,000 will be in the total risky assets. Within the risky assets, you put $113,400 in equities or stocks. The remaining $96,600 are in the bonds. So within the total risky assets, what is the weight or what is the percentage of the equities and the bonds? The weight of the equity of the total risky asset is the dollar amount of market value of equities, $113,400, divided by the total risky assets market value, which is $210,000. So the ratio is 54%, or the weight of the equities, 54%. Similarly, we can calculate the weight of the bond, which is the bond market value, $96,600, divided by the total risky assets market value, which is $210,000. So the ratio is 46%. Or a second way to calculate the bond weight is 1 minus the equity weight, because the sum of the two will always add up to 100%. Then we look at asset allocation in the complete portfolio. A complete portfolio consists of one risk-free asset and one risky portfolio. In our example, the risk-free asset market value is $90,000. The market value of the risky portfolio is $210,000. So the weight of the risky portfolio, which is Y, is $210,000 divided by $300,000, which is 70%. The remaining, or 1 minus 70%, 30%, will be the money you put in the risk-free asset, which is true because if you divide $90,000 by the total portfolio value, $300,000, that is also 30%. Then let's calculate the weight of the equities and the bonds in the complete portfolio. We just need to divide the market value of the equity by the total portfolio's value, and then divide the market value of bond by the total market value of the complete portfolio. You calculate the weight of the equity in the complete portfolio, 37.8%. The weight of the bond in the complete portfolio, which is 32.2%. To calculate the risky portfolio's return, I will introduce the following formula. Assume we only have two risky assets in the risky portfolio. We only have bond and stocks. Then the expected return of the risky portfolio will be proportional to the returns of the bonds and stocks. And it also depends on the weight you put on the bond and the stocks. So the formula goes like expected return of the risky portfolio equals the weight of the bond multiplied by the expected return of the bond plus the weight of the stocks multiply the expected return of the stocks. To calculate the risky portfolio's risk, we use variance and standard deviation. We first calculate the variance. The variance of the risky portfolio depends on the risk of the two assets, bonds and stocks. So the first two terms are variance terms. So the risky portfolio's variance equals the weight of the bond times the standard deviation of the bond, the whole thing squared, plus the weight of the stocks times the standard deviation of the stocks, the whole thing squared. And we also have a covariance term. And in this formula, we express everything in correlation. So it's going to be 2 times the weight of the bond times the standard deviation of the bond times the weight of the stock times the standard deviation of the stocks. The last term is the correlation of the bond and the stock. The standard deviation of the portfolio, or the risk of the portfolio we normally use in this book, is going to be the square root of the variance. The previous formulas on expected return of the risky portfolio and standard deviation of the risky portfolios are very, very important. You will need to remember the formulas by heart. We're going to use it very often in this chapter. So let's take a numeric example to use those formulas. Now we have returns. The expected return of the bond, 6%. Expected return of the stock, 10%. Standard deviation of the bond, 12%. Standard deviation of the stock, 25%. Suppose we put 50% of our money in the bond and 50% of the money in stock. The correlation of the stock and the bond, 0.3, positively correlated. Okay. Now let's calculate the risky portfolio's return, which is going to be weighted average return of bond and stocks. So 50% of the money in bond times 6% return from the bond plus 50% of the money invested in stock times stock return 10%. And similarly, we plug in all the numbers in the standard deviation formula to calculate the risk, which is 15%. Now let's look at the following example. We are going to use a bond and a stock to form a risky portfolio. The expected return of the bond is 10%, standard deviation 30%. The return of the stock 15%, standard deviation 40%. The correlation of the two assets 0.15. Now we want to put a fraction of W in bond, which means 1 minus W in stock. So let's take a look at the whole set of the choices, which is called portfolio opportunity set. To look at the whole set of choices of our asset allocation, we start from 100% money in the bond, which means we put 0% money in the stock. Then we reduce the weight in the bond by 10% each cell. So we start from 100% money in the bond, then reduce to 90% money in the bond, which means 10% money in the stock. We further reduce the bond to 80%, then stock will have 20%. And we reduce the bond until it reaches to 0, which means the stock will be 100%. So if you look at the last row, we are putting $0 in bond, but 100% of investment in the stock. Let's calculate the risky portfolio return and risky portfolio standard deviation. In the first row, when you put 100% money in the bond, the expected risky portfolio's return is the return from the bond, which is 10%. The risky portfolio standard deviation is the bond standard deviation, which is 30%. When we look at the last row in this table, we put 100% money in stocks, so the expected risky portfolio's return will be just the stock return, 15%, while the standard deviation of the risky portfolio is the stock standard deviation, 40%. For all the combination of bond and stocks in between, we have to use the previous formula to calculate risky portfolio's return and the standard deviation. Take the red numbers for example. If you want to put 70% of your money in bond, 30% of the money in stocks, then the risky portfolio's return will be 70% times bond return plus 30% times stock returns. So you plug in all the numbers in the formula to calculate risky portfolio's return, which is 11.5%. Similarly, you put all the numbers in the standard deviation formula to calculate risky portfolio's standard deviation. Once we finish calculating all the possible combinations of stocks and bonds, we can see there are some patterns there. For the portfolio's return, when you increase the money in the stocks, we can see there is an linear increase in the portfolio's return from 10 to 15%. The increase is monotonic. But when you look at the risky portfolio's risk, when you increase the percentage money in the stocks, the risky portfolio's standard deviation at beginning it will decrease, but after some point it starts to increase again, right? So if you look at the sigma p, we start from 30%, reduce to 25.7%, then it increased to 40% again, which means the portfolio's return is linear in the weight W, but the portfolio's standard deviation or the risk is not linear in the weight W. We always talk about the benefits from diversification, but what exactly the benefit from diversification? In the previous table, we actually numerically showed you the numbers of benefits from diversification. If there is no diversification, for example, you hold 100% bond, there's no stock, only bond. The standard deviation of your risky portfolio is the standard deviation of the bond, which is 30%. When you put 100% of your money in stocks, again, there is no diversification, you only have stocks. The risky portfolio standard deviation is 40%, which is the standard deviation of the stocks. But when you diversify, means you hold a portion of bond and a portion of stock. For example, 70% bonds and 30% of the stocks. Then the risky portfolio standard deviation is actually lower, down to 25.7%, comparing to the 30 and 40% of investing bond and stock alone. So that is the benefit of diversification. So now let's plot the investment opportunity set in the risk and return space. The norm is always on the vertical line, we have the expected returns. On the horizontal line, we have the standard deviation. Okay. So now let's plot every single possible combination of stocks and bonds. You will find the shape is a curved shape. Okay. So we have the minimum variance portfolio, which is the combination of bond and stocks that minimize the total risky portfolio's risk. But we also have other possible choices on the pink line. So the pink curve is called investment opportunity set. If we look at the investment opportunity set, you can find not all combinations are efficient. Let's take a look at the portfolio E and portfolio D. Portfolio E and portfolio D has the same level of risk because they have the same level of standard deviation. For the same amount of risk, portfolio E has a lot higher return than the portfolio D. In this case, we say portfolio E dominates portfolio D, which means any rational investor will never choose portfolio D because for the same amount of risk, portfolio E is strictly better. If we look at the cutoff point A, portfolio A is the global minimum variance portfolio. Any portfolio below portfolio A are not efficient. Rational investors will never invest below the point A. So, starting from point A and above is called efficient frontier. And efficient frontier is the opportunity set for investors to choose. Now we have done with calculating the risky portfolio's return and risk. Now let's combine a risk-free asset to form the complete portfolio. In this section, we try to answer a very simple question. If you have $100 and you have three choices, one risk-free asset, say T-bills, one stock, and one bond, of all the three assets, what is your optimal asset allocation among the three assets? Or if you have $100, how much you want to put in each asset? That is the ultimate question we're trying to answer in this section. Remember from the last chapter, the slope of the capital asset allocation line is our Sharpe ratio. The definition of the Sharpe ratio is the risk premium over the standard deviation of the risky portfolio. So now our goal is to calculate optimal risky portfolio, the portfolio A, by choosing the best combination of risky and risk-free asset. So now let's combine the risk-free asset and our risky portfolio together to form a complete portfolio. Again, the pink curve is our investment opportunity set for the risky portfolio. You can pick any possible combination of the stocks and the bond on the pink curve. RF 3% is the T-bill or the risk-free asset return. Basically, if you can connect the 3% risk-free assets return, that point, with any point on the investment opportunity curve, the pink one, you can form a complete portfolio. So each time you combine the risk-free asset with a random point on the pink curve, you will form a capital allocation line. For example, you randomly pick a portfolio A on the pink curve. Then connect that with the risk-free asset. You get the capital allocation line A. If you pick the minimum variance portfolio, the min, and connect that with the risk-free asset, you have another capital allocation line called capital allocation line min. So you can do this exercise multiple times as you like. Each time you pick a portfolio and connect that with the risk-free asset, you get a different asset allocation line. Which one is the best? The best capital allocation line is the one that tangent with the investment opportunity set. So the tangent point is our portfolio O, which is optimal risky portfolio. The optimal capital allocation line maximizes the Sharpe ratio of the complete portfolio. In the previous picture, we have identified the optimal risky portfolio, portfolio O. Now we can combine the portfolio O with the risk-free asset, a T-bill, to form the complete portfolio. So basically, the complete portfolio C can be any point on the optimal capital allocation line, depending on the weight you put in the risk-free asset. Asset allocation is the process to find the optimal weight you put in each asset of your complete portfolio. Now we're going to look at this numeric example to review all the formulas and concepts we have learned in this chapter. Once you're done with this numeric example, you will be crystal clear of what is exactly capital allocation and what question we try to answer. Now suppose you are a portfolio manager and you have different clients asking you to help them to find optimal weight of different assets. Here's the problem setup. You have 3 assets to choose from to form your complete portfolio. The first asset is the T-bill with return 1% and the risk 0. Because in the setup, we always assume the T-bills are risk-free asset, means there is no risk, no standard deviation. And you also have 2 risky assets to choose from. One is Google stock, the other one is Apple stock. The expected returns and standard deviations are listed in the table. The correlation of the 2 stocks, 0.54%. Now, as the portfolio manager, you have 2 clients. Client A has a specific need. Client A wants to have a minimum variance portfolio, and client A's risk aversion level is 4. A second client, the client B, wants to have a portfolio with at least 3.25% return, and his risk aversion level is 3. To find the best combination of Google, Apple, and T-bills for your 2 clients, the first step is we're looking at the risky portfolio. Means we are going to ignore the T-bills first. We are only going to look at risky assets. In this case, Google and Apple stocks. If we only look at the risky portfolios, the 2 formulas we're going to use are the expected return of the risky portfolio and standard deviation of the risky portfolio. Okay, I listed the 2 formulas at the top of the slides. Then we are going to create the big table we did before. To find the best combination of Google and Apple, we are going to first list all possible combinations of the Google and Apple. Okay, we start from 100% money invested in Google, 0% money in Apple. Then we gradually decrease the weight in Google and increase the weight in Apple by 10%. Of course, you can decrease the weight of Google by 1% each time. In that case, you are going to create a 100 rows table, but we don't have time to do that. For illustration purpose, we're going to decrease the weight of Google by 10% each time. Okay, until you reach 0% money in Google and 100% money in Apple. Okay, then we are going to use the two formulas in this slide to calculate risky portfolio return and risky portfolio risk. So basically, you just need to plug in all the numbers presented in the problem set in those two formulas to calculate risky portfolio's return and risk. Okay, all right. Now we are ready to pick the best combination for our clients in the risky portfolio. Client A says he wants the minimum variance portfolio. Then let's check which risky portfolio has the lowest standard deviation. When you look at the table, when you put 50% money in Google and 50% money in Apple, the risky portfolio has the lowest risk. The risk level or the standard deviation is 7.91%. So that is the combination you will recommend to your client A. Client B says, to minimize the portfolio variance, but at the same time, give me at least 3.25% return. That is simple. You will pick the blue portfolio. You want to put 30% of your money in Google and 70% of your money in Apple for client B, because client B needs a return at least 3.25%, and the blue portfolio is for him. As the portfolio manager, your second step is to find optimal weight of the risky portfolio. So in the first step, we already found the best combination of the risky portfolio for our clients. Now we are going to bring in the T-bill or the risk-free asset. Here we are going to use the formula in the green box. Y star is the optimal weight you put in the risky portfolio. So for client A and client B, we are going to put in different risky portfolios return and standard deviation because they chose two different risky portfolios. For client A, the optimal weight to put in the risky portfolio is 78%. For client B, 97%. Because client A and client B have different risk aversion level and they also pick the different risky portfolios in the first step. Finally, in step 3, the portfolio manager will help the client to form the complete portfolio and calculate the complete portfolio's return and risk in the following two formulas. And again, we can just plug in all the numbers we had before for both client A and client B. Now we are done with the asset allocation problem. Following the 3 simple steps, we found the weight for all the risky assets and the risk-free asset to help our clients to form his complete portfolio. Now let's do some exercise. Which one of the following portfolios cannot lie on the frontier? The correct answer is A. Only portfolio W cannot lie on the frontier. Why? Because if you look at the portfolio W and comparing that with portfolio Z, portfolio Z has a higher return 12% versus 9%. But at the same time, portfolio Z has a lower risk, lower standard deviation 15% versus 21%, which means we can say portfolio Z dominates portfolio W, or portfolio Z is strictly better than portfolio W. So portfolio W cannot be on the efficient frontier. Portfolio theory as described by mean variance efficient frontier is mostly concerned with B, the effect of diversification on portfolio risk. We are mostly concerned with reducing the portfolio risk by combining risky stocks or bonds with different return patterns. A is not right because systematic risk can never be get rid of. C, identification of unsystematic risk. This is wrong because in a diversified portfolio, the unsystematic risk or the firm-specific risk is diversified away. We don't even need to worry about that. D. Active portfolio manager to enhance returns. That is also wrong because in our model, there is no room for the active portfolio manager to enhance returns because all rational investors will choose on the efficient frontier and capital allocation line. The measure of risk in the efficient frontier is standard deviation of the returns. So far, we are only going to use standard deviation as the measure of risk. As shown in all our pictures before, we are going to introduce another measure of risk in the next chapter, and I will show the difference between the two. Suppose you have $1 million to construct a complete portfolio. The risk-free asset, 12% return, 0 risk. Risky asset, 30% return, 40% risk. Now, if you want to construct a portfolio with standard deviation of 30%, what is the return of your complete portfolio? Well, the first step we need to do is to calculate the weight you put in the risky portfolio. To do that, we can use the formula to calculate complete portfolio standard deviation. So the sigma C is 30%, which equals 40% times the weight you put in the risky portfolio. So the weight is 75%. Now we know 75% of the money is in the risky portfolio, 25% of the money is in the T-bill. Then we can calculate the complete portfolio's return by calculating the weighted average return of the risk-free assets and risky asset. Now we have the complete portfolio return 25.5%.